Hello children, today we learn about what is a Pythagoras property. Before that, we have to know about right triangle, as Pythagoras property is applicable only for a right triangle. So, a triangle in which one angle is 90 degrees is called a right triangle. So, in this triangle, the side opposite to right angle is called hypotenuse, and the sides which contain right angle in between are called legs of the triangle. Here, hypotenuse is the longest side of the right triangle. Now, the Pythagoras property is given by a great mathematician Pythagoras. He discovered an important property related to hypotenuse and the remaining two sides of a right triangle, which is known as Pythagoras property. So, let us see now the statement of the Pythagoras property. In a right triangle, the square of hypotenuse is equal to the sum of squares of other two sides. That is, if we observe here in this right triangle, C is the hypotenuse and A and B are the other two sides. So, according to the statement, A square plus B square should be equal to C square. Now, let us prove this statement. For that, let us take a right triangle ABC of sides 3 cm, 4 cm and 5 cm. Now let us take a square of side 3 cm on side AB. Similarly, we take another square of side 4 cm on BC and a square of side 5 cm on AC. Now let us find the areas of these squares. As we know, the formula for area of square is side into side. The area of this square will be 3 cm into 3 cm, as each side is 3 cm, which is 9 cm square. And the area of this square will be 4 cm into 4 cm, which is equal to 16 cm square. Now the area of this square will be 5 cm into 5 cm, which is equal to 25 cm square. Now if we observe here, 9 cm square plus 16 cm square is equal to 25 cm square. As we observe here, each square is divided into squares of 1 cm each, whose each area would be 1 cm square. Now if we arrange these two squares into this bigger square, they would fit exactly. That means the sum of the areas of these two squares is equal to the area of the square on this hypotenuse. Therefore, we can say that AB square plus BC square is equal to AC square. So finally, it is proved that the square of hypotenuse is equal to the sum of squares of legs of the right triangle. So remember children, this Pythagoras property is applicable only for right angle triangles. Now let us see what are Pythagorean triplets. A set of three non-zero natural numbers A, B, C is called a Pythagorean triplet if A, B, C satisfies the Pythagoras property, that is, A square plus B square should be equal to C square. That is, A, B, C form three sides of a right triangle. For example, 3, 4, 5 is a Pythagorean triplet, as 3 square plus 4 square is equal to 9 plus 16, that is 25, which is equal to 5 square. So, some more examples of Pythagorean triplets are 6, 8, 10, 14, 48, 50, 16, 63 and 65. But how can we find some more Pythagorean triplets like this? There is a formula to find Pythagorean triplets, that is 2m, m square minus 1, m square plus 1 for m greater than 1. Now let us see some examples to form the Pythagorean triplets. If m is equal to 3, that is 2m becomes 2 into 3, which is 6. M square minus 1 is equal to 3 square minus 1, which is 9 minus 1, that is 8. and m square plus 1 is equal to 3 square plus 1, which is 9 plus 1, which is equal to 10. Therefore, the Pythagorean triplet is 6, 8, 10. Let us see one more example. Find the remaining two numbers of a Pythagorean triplet whose first number is 16. As we know here, the first number is 2m. Let us equate it to 16. So, m becomes 16 by 2, which is 8. Now, substitute this m value in the other two numbers, that is m square minus 1, which is equal to 8 square minus 1, that is 63, and m square plus 1, which is equal to 8 square plus 1, that is 65. Therefore, the Pythagorean triplet required is 16, 63 and 65.